Sometimes you want to use static fields inside of a class, and you just need to be aware of how static fields and generics interact. So let me delete some of the code that I had here previously. And let's say that item has a static field called instance count. And I'll make that a public static field. And every time an item is constructed, instance count will be incremented. So here in the main method, I'll create one new item and two new items, and maybe even a third item. And it probably won't surprise you if I write out item.instanceCount that the value of that will be 3, which it is. That's good. Because as you probably know, static fields are shared across all instances of item. Therefore, there's only one instance count, and we can use that to track the number of items that have been created. But what happens when item gets a generic type parameter? So now when I construct an item, I have to construct, let's say, an item of int, and an item of int, and an item of string. And now the question is, will instance count be shared among all those instances of item, both the ones of type int and string, or will something else happen? Well, the first clue that something else might happen is that I can no longer just get to item.instanceCount. I need to specify the generic type parameter here even when I'm accessing a static field. So I have to say, let's write line the item of int instance count, and let's write line the item of string. And now let's run the program and see that we get 2 and 1. And this is a great insight into how generics work. When I create a class definition is a blueprint for creating objects. So every time I use the new operator with a class, something behind the scenes is using that class definition to create the new instance of the object. To back up one step further, one way to think of generics and how they work on a class is that a generic type is a blueprint for creating classes. So when I declare a class like item of t, what I'm declaring is a blueprint so that at runtime, when someone actually uses an item of int, the CLR and the JIT compiler can combine that information together and create a new type, a class definition for an item that only stores integers. And then it can create an instance of that particular type. But since it created a new type, an item of int, only instances of that new type, item of int, share the static field instance count. So it's not possible to share a static field across all these different generic types, item of int and item of string, because they're actually individually separate types. If that's something I wanted to do, again, that's a case where a base class can come in useful. I can have public class item, move this code into my item, and have item of t derived from item. And now when I run the program, I get 3 and 3. So this is where statics become a little bit weird actually, because I'm accessing instance count through a derived type, item of int. But since there is no static field on item of int itself called instance count, what we're looking at is really item.instanceCount. And in fact, I'd feel a lot more comfortable writing this as item.instanceCount, because that's actually really the field that we're looking at. And with some plugins in Visual Studio, they will actually give you the warning if you tried to write item of int.instanceCount that you're getting to a static field through a more derived type than where that field actually is defined. Much safer to place it here, because if I really want the instance count that is shared among all these different items, this is the one I would want. And that's just something to be aware of with generics.